So the last thing that we're going to look at is called spanning trees. And what a spanning tree does is it tries to get to connect every single node, all right? It's not about traveling across it, it's just connecting all the nodes that we have in our diagram, all right? What we don't want is we don't want any circuits, so we don't want any circles, because if we've got a circle, that means that we've done one side too much. So if I've got 4 dots and I want to join them in the least possible ways, I just join 3 of them. I don't need to join that one, it's already part of it. So we never have a connection backing it up. So the way we're going to do this, and the proof we need, is called Kruskals. I told you it was the topic of strange names. Kruskals Algorithm. There's only one method for this one. There is trial and error, but it's better if you have a method, then you know you've done it right. So if we're looking at this one here, what we do with Kruskals is we write down all the connections. So we start at A, and we go A to X is 12. A to E is 8. And A to B is 16, all right? You don't need to put any more in that are connecting up to A. So we go somewhere else next. So let's go to B. So we've already done B to A, we don't do it again. We're going to go B to E is nothing at the moment, so I'm going to put 5 on there just because I can. And B to F is going to be 10. B to D is going to be 7. B to C is going to be 8. All right? So I don't need any of those paths again. So I've got C to D. I haven't got that written down here, and the other way around is 12. I've got D to F, which is also 12. I've got E, 2. Got E once, E twice, so I need an E to X, which is 6, and an E to F, which is 5. The last one is F to X, which is 8. So once I've got my table with everything in it, I can now work out what I need to do. Now, I'm not just about joining them up. That would be what a spanning tree is, but what you're actually trying to do is you're trying to span it in the least or most, so the minimum or the maximum value you can get out of the dots. All right, so an example here would be you've got however many houses that is, 1, 2, 3, 4, 5, 6, 7 houses, and you're trying to connect them up, and you want to use the least amount of connection cost that you can. So in that particular case, you'd be looking for a minimum spanning tree. So the way you do it is you look at your table and you decide that the first thing you're going to do is pick the smallest number in your table. So the first one that I came across that's the smallest is D to E, and I'm going to colour that in. So I have coloured that one there in. All right? Might have been better to do it in red, but anyway. So because it's a minimum, I look for the next smallest one, which is E to F. So I'm going to colour that one in. It was 5. Okay? I don't want to go backwards, so I don't ever want to colour in B to F, okay, because B to F makes a circle. So I'm not interested in that 10. The next one I'm interested in is 6, which is E to X. All right? I have now connected all of these ones here. All right? I don't have to have the outsides I haven't got A, but let's see what happens next. So we go down, A to E is 8. So we're going to get to A by using the 8. There we go, now we have. Then I've got to get to D and C. So I want the smallest one that I can find with D and C in it. So here's D, it's 7. So I've got this one. And C, smallest one with C in it, is this one. So that blue spider-looking thing, I draw it out. I've got this one, this one, this one, this one, this one, and this one. That spider-looking thing is the minimum spanning tree. It's got a value of 6, 8, 5, 5, 7, and 8. So we would add up that for its value. Equals 10, 25, 31, 39. 11, 19, 24, 31, 39. Right. 31 whatevers. Let's say it was kilometres. All right, it will have a unit of some sort. It will be dollars, or it will be kilometres, or it will be kilograms, or whatever it happens to be, some sort of measurement. All right, so that's a minimum one. Finding the small. What do you think we do for the maximum one? Exactly the same process, but this time with the maximum. Now, there would be reasons why we want to find the most possible cost. Maybe we are trying to gain money out of something. So we'd do exactly the same thing, but this time looking for the biggest one. So the biggest ones are 16. So 16, that's my first one. All right, then I've got 12, A to X. I'm going to keep that one as well. Then I've got another 12 here, C to D. And I've got a D to F. Right, those are my maximum ones that I can see clearly. I need to make sure I'm connecting it all up, so I still need to go to E, and that's it. I just need to go to, oh no, I've got to connect this one up to that one. So I need to connect to E. So this is the next most big one, 10, this one. So I'm going to go here. Now I've got all of those ones connected. And I need to connect to E, and the biggest one is to connect it to A. That one. All right, so that would be our maximum tree. So we would have the value of that one as 12 plus 12 plus 12 plus 10 plus 16 plus 8. 20, 30, 40, 50, 54, 60, 70, I think. 24, 36, 46, 56, 62, 70. Right. And what does it look like? Quite different. So it looks like this time. All right. So what we are drawing here is the spanning tree. 12, 16, 8, 10, 12, 12. Okay, so we are trying to get either the minimum value or the maximum value, and you have to read it correctly to be able to actually determine those things. Any questions?